Welcome to Mr. Chalk's Revision Tips. In this video, we will look at the plum pudding model, the alpha scattering experiment, and atomic theory, or nuclear atomic theory. So an atom is the smallest piece of an element that can exist. All atoms have a nucleus that are made from protons and neutrons and have electrons orbiting them in shells. So the plum pudding model was where we discovered, or after we discovered electrons, and was a very early model of what an atom could have looked like. The alpha particle deflection experiment proved the existence of the nucleus, and the atomic model is how we go and think about how an atom might well look now. So ideas about atoms have changed greatly over time. So scientists developed a new atomic models as they've gained more evidence. John Dalton published his ideas about atoms in 1803. So he thought that all matter was made of tiny particles called atoms, which he imagined to be tiny spheres that couldn't be divided. Nearly 100 years later, J.J. Thomson carried out experiments and discovered the electron. So this led him to suggest the plum pudding model of an atom. So in this model, the atom is made of a positive ball with negative electrons dotted around it, a bit like a plum pudding. So if we think about this question, so over 100 years ago, scientists thought an atom looked like a plum pudding. The diagram above shows the plum pudding model of the atom. The scientists knew that the atom was negatively charged particles. They also knew that an atom had no overall charge. What did scientists conclude about the charge of the pudding part of the atom? So the way that you would go and answer that is that because it had no overall charge, the amount of positive charge must have been equal to the amount of negative charge. In 1909, Ernest Rutherford designed an experiment to test the plum pudding model and see whether this was actually the case. In the experiment, positively charged alpha particles were fired at thin gold foil. Most of the alpha particles passed straight through, but a few were scattered in different directions. So because most of the particles went straight through, that showed that most of an atom must be empty space. Some alpha particles were deflected, showing that the nucleus of an atom must be positively charged because alike charges repel. And because a few alpha particles were deflected back, that suggested that the nucleus must have been dense and in the center to enable it to go and bounce the alpha particles back towards the source. So if we look at this question, so two scientists named Rutherford and Marston devised an experiment to investigate the plum pudding model of an atom. The experiment involved firing alpha particles at a thin gold sheet. The scientists measured how many alpha particles were scattered. The results of the experiment showed that the plum pudding model to be replaced by the atomic model. So the reasons why: a significant number of alpha particles were scattered, the alpha particles, or some were deflected backwards, the measurements that they took experimentally could not explain the plum pudding model, so therefore they had to replace that model based on new data. So if we're looking to suggest one reason why other scientists thought the experiment proved that this was valid, It's about the fact that they took lots and lots of results, and it helped that the two scientists were already known and respected by the scientific community at large. Rutherford's atomic model became known as the nuclear model. In the nuclear atom, the protons and neutrons, which comprise nearly all of the mass of an atom, are located in the nucleus at the center, and the electrons orbit around it. So the nuclei of all atoms contain subatomic particles known as protons and neutrons. The center of an atom is known as the nucleus and is surrounded by shells of electrons. And the mass of an electron is very, very small compared to a proton or neutron. So since the nucleus contains protons and neutrons, most of the mass of an atom is concentrated in its nucleus. So if we look at this question, in 1931, scientists thought that atoms contained only protons and electrons. Suggest what happened in 1932 to change the idea that atoms contained protons, electrons, and something else. So it's just about the fact that the neutron was discovered in 1932. The table gives information about the particles in an atom. Complete the table by adding the names of the particles. So have a look at the table, pause the video, decide what you would put, then have a look at the answer. So the first one would be neutrons, because it's got a mass of 1 but no charge. The second would be electrons, because they're very small but they have a negative charge. And finally, the third would be a proton, because it's got a mass of 1 with a positive charge. Describe the model now used for the structure of an atom. In your answer, you should give details about the individual particles that make up an atom and include the relative masses of those subatomic particles. So have a think about how you would answer that, then have a look at the answer. So things that you might want to include are that protons and neutrons make up the nucleus, electrons orbit the nucleus in shells, most of the atom is empty space, the nucleus occupies only a very small fraction of the volume of the atom, electrons orbit the nucleus at various distances, and the nucleus is positively charged because it is only made up of protons and neutrons. Thanks for watching.